In this video, we will be talking about infinite geometric series. Basically, this is going to be the last part of our sequences and series chapter for pre-calculus. Now, for infinite geometric series, basically, the formula is enumerated by the following. S is equal to a sub 1 over 1 minus r. By the word infinite, this time our geometric series, the sequence particularly, like this one, like this example, it's basically unlimited. This can go on forever as it is multiplied by its corresponding common ratio. So that's what we mean by infinite. That's how it differs compared to finite geometric series. For finite, usually the problems ask a specific, find the specific s sub n. But for infinite, find the sum provided that we have our a sub 1 and our common ratio. That's all for infinite geometric series. So, without further ado, now that we've discussed the difference between infinite and finite, I may have left a few important details too, but as for this worksheet, that's all that we have to know, I suppose. So let's just highlight this. There you go. Infinite geometric series. Let's start with our test one. By the way, just another important detail that you have to know. For the sum of infinite geometric series, something that you have to know is that we cannot find the sum, which is this one. We cannot find it if the series diverges. What by the term diverge, such that a typical common ratio done with absolute value is greater than 1. That means in this case we cannot, the sum is impossible. The sum does not exist. And on the contrary, series converges. It's basically the opposite of diverges. So the common ratio processed with absolute value is still less than 1. In that case, we can find the sum. So those are the things that we have to know before we start. So yeah, I think that's all that we have to know. Let's start. Determine if each geometric series converges or diverges. So just what we discussed a few seconds ago. Oops, wrong highlighter. This one. All right, sweet. First, we have to determine absolute value of our how do you say this? The common ratio. So r is equal to 2 common ratio, which is greater than 1. So in that case, our series diverges. Alright. In that case, sum does not exist. For number 2, okay, r is equal to negative 3 over 4 absolute value. This will be positive. So positive 3 over 4 is basically smaller than 1. This is a proper fraction. All proper fractions, I think, are below the quantity of 1. And proper fractions can be higher than 1. So yeah, that's how the way fractions work. So in line with our lesson right now, series, let's just copy paste. Series converges. There you go. Alright, let's move to number 3. R is equivalent to 0.5. Absolute value, this is already positive anyways. It's less than 1. So the series also converges, just like what we have in number 2. So, for number 4, r is still 3, absolute value is still positive 3. 3 is greater than 1, therefore, our series diverges. I hope you're getting the pattern now. Let's skim through a few more examples, just in case you haven't understood it fully yet. So, common ratio. Actually, we have to find it manually in these kind of problems. These kinds. So, 27. Dang, I forgot my calculator with me. I'll use the other one. 27 divided by 81 is 1 over 3. R is equivalent to 1 over 3. Absolute value, it's less than 1. So, series converges. For number 6, let's find our common ratio again. Divide a sub 2, a sub 1. A typical solution that we used to do in the previous videos. Hope you've watched them. So 17.5 divided by 7.1 is 5 over 2. This is an improper fraction, so it's most likely, if we turn this into a mixed fraction, it's greater than 1. Therefore, the series diverges. Place the absolute value there. There you go. Let's move to number 7. R is equivalent to 12.5, 12 over 5 divided by negative 3. R is equal to negative 4 over 5. Make this positive absolute value. It's still less than 1. Proper fraction. So, therefore, the series converges. Let's move to number 8. R is equivalent to, let's divide negative 64 over 6 to 5 divided by 128 over 3125. R is equivalent to negative 5 over 2. Absolute value, this will be positive. This is greater than 1. Just like number 6. I think it's a coincidence, maybe not, that the common ratio is the same. Weird. So series diverges. Let's move to number 9. Alright. Let's just check what we have so far. Series diverges, converges, diverges, 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 converges, converges, converges. Yep, all correct. Don't worry. All these corrections are based on the answer key. I have another iPad here, and yeah, I've already I've already checked these before the video, so just sit back, relax, listen to the video, to what is being taught, and you'll be good for the exam, hopefully. Alright, so for number 9, just like our usual drill, we find a sub 1. So negative 4, there's no parenthesis. Negative 4 raised to 1 minus 1. Substitute values. Place that in the calculator. Our answer is negative 1. Experimentation. Yeah. There's a difference, alright? If you have this, you get positive 1. You have to ponder the difference between these two. You have to be very sharp when it comes to whether the given has parentheses or not, because that will ultimately determine whether your answer will be correct or not. So just like this, it's very crucial, very sensitive. Right, back to the topic. Negative 1 is equivalent to a sub 1. There you go. And alright, given that we know a sub 1, it could be said that, give me a few seconds to think. I see it. So, negative 1 is equivalent to a sub 1. Alright. 4. So given that a sub 1 is negative 1, so that means this would be 4. The 4 would then be our r, because this altogether makes this negative 4. So r is equivalent to 4, by which is greater than 1. Therefore, the series diverges. Oops, I should remove this. There you go. Actually, yeah, this is already correct too. This one. Let's move to number 10. Alright, find a sub 1. 16 over 9 times 3 over 2 raised to 1 minus 1. Given that, basically our answer, a sub 1 is equivalent to 16 over 9. I think. Yeah, this isn't simplified yet. Oops. Supposedly it could be 4 over 3, but we'll let it be like this. 16 over 9. Well, yeah, technically this is 16 over 9, so a sub 1 r raised to n minus 1, just like the geometric sequences formula exactly in this kind of trend. Oops. Highlighter is very thick. There you go. Alright. Therefore, we could derive that r is equivalent to 3 over 2, which is greater than 1. So, series diverges. There you go. Let's move to number 11. 4.2 times 0.2 raised to 1 minus 1. Our answer for that is 4.2. That is our a sub 1. Well, technically, even if we don't use this, if we don't solve it with this, you could already see visually that this is a sub 1 and this one is r. Therefore, if r is equivalent to 0.2, it's less than 1. Therefore, series converges. There you go. Let's move to number 12. Alright, let's not do it traditional anymore. A sub 1 r, let's do it the simplified way, the easier way. So given that r is equal to negative 1 over 4, absolute value, so this will be positive, it's still less than 1. So series converges. Just copy paste, fastest way, benefits of digital writing. Evaluate the infinite geometric series described. So, what we mean by evaluate, this is where the formula comes handy. Again, the formula is S is equivalent to a sub 1 divided by 1 minus r. In that case, for number 1, we'll just use the given. We'll utilize the given in order to complete our formula so that we could find the sum, which is basically evaluating the geometric series, the infinite geometric series that is given, this described. So, S is equivalent to a sub 1 divided by 1 minus r, whereas a sub 1 is 3, and our r is negative 1 over 5. Please do not confuse the negative signs. This is naturally a minus sign, and if your common ratio has a negative sign, that means there's a negative. Don't be confused that this is going to be positive. That's going to lead you to the wrong answer. So please be careful with the operation signs. One simple mistake can lead to the entire answer's mistake, or the entire answer's demise. 3 divided by, 3 over 1 minus negative 1 over 5. Place that in the calculator, we get 5 over 2. So that's how we evaluate, that's how we calculate the sum for infinite geometric series. Let's move to number 14. Alright, so I think we forgot to assess first. R is equivalent to 1 over 5 such that there is absolute value. It's it's less than 1, therefore we can compute the sum. Sum exists. For number 14, let's assess if our common ratio is less than 1 or greater than 1. So -4, absolute value, this will be +4. It's greater than 1. Therefore, series diverges. Therefore, no sum. We don't have to use the formula anymore because there's no sum really. Alright, let's move to number 15. Let's check. R is equal to -3, absolute value, make it +3. It's greater than 1, therefore series diverges also. Therefore, we don't have any sum. You should be really careful with that. Some students, unfortunately, they don't check their common ratio before they even calculate for the sum, because even if you calculate the sum, naturally the given doesn't have a sum. So yeah, I did my mistake a while ago. I forgot to assess first, but yeah, I hope you've also learned that lesson. Both of us experienced it right now. You as the audience and I as the writer right now, teacher. So yeah, all of these are correct according to the answer key. Let's move to number 16. So let's check. R is already positive, so 1 over 2. We don't have the absolute value. Actually, yeah, let's make it sure. It's less than 1. Therefore, series converges. Therefore, we can find the sum. S is equivalent to a sub 1 over 1 minus R. Well, we place this in the calculator, the expression, and what we get is 2. The sum is 2. Alright, let's move to number 17. Alright, A is equal to 1. R is equal to, let's place a calculator, 0.5 divided by 1, 1 over 2. Let's try again, make sure that R is really 1 over 2. 0.125 divided by 0.25. Yes, it's still the same answer. R is equivalent to 1 over 2. So let's assess. R is equivalent to 1 over 2. It's less than 1. So it so converges. And therefore we can find the sum. So S is equivalent to a sub 1, which is 1, over 1 minus R. In that case, S is also 2, similar to the answer a while ago, but I doubt it was a coincidence. This is correct. Let's move to number 18. A sub 1 is equivalent to 3, and R is equivalent to -3 over 4. Let's prove. Alright, -9 over 4 divided by 3 is -3 over 4. Extra proof, -81 over 64 divided by 27 over 16 is still 3 over 4. Therefore, this is correct. We can ensure. So, let's assess. R is equivalent to +3 over 4, such that there is absolute value, and it's smaller than 1. Therefore, the series converges. Now, given that the series converges, let's find our sum. S is equivalent to 3 over 1 minus R. Therefore, S is equivalent to, place this in the calculator, our answer would be 12 over 7. Alright, Let's move to number 19. A sub 1 is equivalent to 81. R, our common ratio, negative 27 divided by 81. We get negative 1 over 3. Negative 3 divided by positive 9, we still get negative 1 over 3. This is indeed correct. I'm sure of that. Let's find, actually, assess first. I almost forgot. R is equivalent to negative 1 over 3. Make this positive, which is less than 1. So, converges. Series converges. Therefore, we can find the sum. S is equivalent to 81 over 1 minus negative 1 over 3. Our answer would be S is equivalent to 243 over 4. Now, I have to tell you this. Some teachers, some math teachers prefer the final answer to be in fraction, or they prefer it in decimal. So, choose whatever your teacher prefers. Please ask him or her about which is more accurate in her opinion. Or probably, it couldn't be opinionated usually. But I think it really is just better to generalize, enumerate the fraction form and the decimal form. So yeah. The only catch there is to see how accurate the value is. Let's move to number 20. A sub 1 is equivalent to 1. Common ratio, negative 0.6 divided by positive 1 is negative 3 over 5. 0.216 divided by 0.36 is... strange. Yeah, I forgot the negative symbol, that's why it seems strange. It's there, yes. R is equivalent to negative 3 over 5. So, assess 3 over negative 3 over 5, absolute value, this is positive now. It's still less than 1, so converges, series converges. Therefore, we can find the sum. S is equivalent to A sub 1 divided by 1 minus negative 3 over 5, which is, in other words, 1 minus R. Now, if we put this in the calculator, we get 5 over 8. Why is this a circle? Get 5 over 8, or we get S is equivalent to 0.625, 0.625. Right, let's move to number 21. Let's find A sub 1. Let's just cut it short. We already know what it is, obviously. So A sub 1 is equivalent to 5. And we also know what R is. It's this one. R is equivalent to negative 1 over 5. So technically we can already solve. Assess first. I almost forgot again. So absolute value, this is 1 over 5. Still less than 1. So we can solve for the sum. S is equivalent to 5 divided by 1 minus negative 5. So in that case, S is equivalent to 25 over 6. Alright, let's move to, let's enumerate the fraction also. Let's get the best of both worlds. Those who prefer decimals as the final answer and those who prefer fractions. Alright, let's find A sub 1 is equivalent to negative 6. R is equivalent to negative 1 over 2. So, in that case, it says if series converges or diverges, negative 1 over 2, absolute value. Alright, 1 over 2 is less than 1, so we can find the sum. Speaking of finding the sum, S is equivalent to negative 6 divided by 1 minus negative 1 over 2. S is then equivalent to negative 4. Alright, let's move to number 23. Number 23, again, our good rule of thumb, whatever the number appears here, that's already our R. And whatever the invisible number is, which is technically 1, I think that's also involved in the law of exponent. 2 can be rewritten as 1 times 2. So in this case, our usual form is this is R and this is a sub 1. Considering this is being inferred to geometric sequences. So R is equivalent to 1 over 3. A sub 1 is equivalent to 1. So we know that 1 over 3 is less than 1, so converges. So S is equivalent to A sub 1 divided by 1 minus R. In that case, S is equivalent to 3 over 2. There you go. Let's find number 24. So again, let's apply the technique. R is equal to 4, we know it already, times the invisible 1. Invisible 1 is A sub 1. And in that case, let's check the value of our sum. R is equal to 4, absolute value, it's already positive anyways. But it's greater than 1. So we know what that means. It's a drill. Series diverges, div. It's abbreviated as div. Because of that, we cannot find the sum, because there is no such sum in this given. Right, let's check now from numbers 20. 20, 0.625, 4.17 or 25 over 6. S is equal to negative 4. This is no sum, this is 3 over 2. Alright, so far so good. Let's move to number 25. So determine the common ratio of the infinite geometric series. In other words, we have to find R. So R is missing. Considering that we have this, we have the given, we have A sub 1, and we have our S, our sum. I haven't made a video about this yet, but basically what the instructions is trying to say is that it's similar to solving literal equations. Literal equations is a lesson discussed in grade 7 math. If that's not discussed in grade 7 math, well, it is in my school. But yeah, basically literal equations involves finding two variables such that, I'm not sure how to explain this anymore, but I don't want to confuse you. Basically, it's a matter of algebra. So given that we have S, we have A sub 1 over 1 minus R, we'll just substitute the values that we have. So 1.25 is equivalent to 1 divided by 1 minus R. So we know the two values, but we don't know what R is. So in this case, we'll multiply both sides by 1 minus R to disregard the denominator. We don't have much space there. There you go. Move that, looks weird. 1 minus R, distributive property. Let's move it here. So 1.25 minus 1.25R is equivalent to 1. 1.25, move 1 to the left side, so this will be minus 1. Move this to the other side, we have 1.25R. So we have 0.25 on the other side is 1.25 as is. Divide both sides by 1.25. R is equivalent to negative 1 over 4. Alright, so we found a common ratio. Yay! let's double check. 0.25 divided by 1.25 is I'm so sorry. I was wrong. I'm wrong. The answer is 1 over 5. It's a good thing that we've double checked. R is equivalent to 1 over 5, or consider the decimal form. R is equivalent to 0.2. Alright. We found the common ratio of number 25. Let's move to number 26. This case, alright. It's a matter of algebra. Again, S is equivalent to a sub 1 over 1 minus r. Multiply both sides by 1 minus r to disregard the denominator. There you go. 64 minus 64r is equivalent to 96. So 64 minus 96 is equivalent to 64r. Just basic transposing methods. 64 minus 96 is negative 32 is equal to 64r. Divide both sides by 64. R is equivalent to negative 1 over 2. There you go. That's how we get our common ratio. R is equivalent to, in other words, negative 0.5. Alright. We finished number 26. Let's move to number 27. So the same strategy. So S is equivalent to a sub 1 divided by 1 minus r. Multiply both sides by the denominator. Let's move this again. We lack space on the left side. There you go. And we don't have the denominator on the right side, so this is negative 4. Distributive property, negative 16 over 5 plus, so double negative will be positive, plus 16 over 5r. We have another problem. We have a denominator of 5. So we'll remove it, multiply both sides by 5. It will be negative 16 plus 16r is equivalent to negative 20. 16r is equivalent to negative 4. Put this to the other side, negative 16 becomes positive 16. Positive 16 minus 20 is negative 4. So divide both sides by 16. R is equivalent to negative 1 over 4. That's how we get our common ratio. Let's move to number 28, the last number, finally. 2.5 is equivalent to 1 minus 1 over r. 1 minus r. So 1 minus r on both sides. So 2.5 minus 2.5r is equivalent to 1. 2.5 minus 1 is 1.5. Move 2.5r to the other side, we get positive 2.5. And divide both sides by 2.5. R is equivalent to 1.5 divided by 2.5 is 3 over 5. So R is equivalent to 3 over 5. Or, in decimal form, is R is equal to 0.6. There you go. So I can assure you again, just as I said earlier, these answers are reliable. I've checked it beforehand, before this video was even made. So yeah, don't have to worry much about. I'll be reviewing this video just in case I make a mistake, but most likely there won't be a mistake. I've answered this before. I've made a copy, and I can assure you my answers, my solutions are not prone to error. So again, let's recall. So this is the first part. This is how we solve it. the second part. Right? Evaluate each infinite geometric series described. Let's move to the next. There you go. And this part. Alright, I suppose we're finished. So here below are the answer keys. I mean, it's singular. Here below is the answer key. So this worksheet is available in the internet. You can just search it up, Infinite Geometric Series, Kuta Software, Infinite Algebra 2, and you could practice by your own. As a few math YouTubers say, practice is the only solution to success in your exams. So after learning what I've taught you in how to answer this worksheet, I hope it really helps, and I'll see you in the next video. The next video would be no longer about sequences and series. I'll be introducing a new topic that might be relevant to your high school curriculum. Goodbye and thank you.